Greetings folks, welcome to another edition of Mr. D Teaches Math. Today's video is going to focus on something called the zero principle. And what I'm hoping that you're able to do is to be able to add positive and negative numbers using the zero principle. The zero principle is very helpful for addition of fractions. It's also helpful in using in subtracting fractions too. So, to do a little exploration, the other day I wondered if a tossed coin would land heads or tails the same number of times. I was thinking back to our unit in Unit 9, we talked about probability, about the likelihood of something happening, the theoretical or experimental probability. And so what I decided to do is I designed this little experiment where I tossed a coin 20 times as an experiment. So what happened was when I tossed heads, I gained 1 point, and when I tossed tails, I lost a point. Now again, notice positive 1 is in red, negative 1 is in blue. So I carried out the experiment, and I thought I would share with you my first 11 results. And so my question that I'm looking at is how can I add integers to calculate my score? Now, it might be helpful to have a couple of definitions before I kind of carry on with this little description. And so the first one that I wanted to talk to you guys about is the zero principle. Now, what the zero principle says is that I can have two opposite integers, and I can add them together. They give a sum of zeros. So, for example, if I have a positive 1 and I add a negative 1, they kind of cancel each other out. They kind of just equal 0, right? So, like on a number line, they're the same distance apart, and that gets me to the second definition of opposite integers. And it's two integers which are the same distance away from 0. So, for example, positive 6 and negative 6 are both the same distance away from 0 there in the middle. Okay? And so if you add those opposite numbers together, you still get 0. So, here are my first 11 results. So you can see I tossed tails, tails, heads, 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 tails, heads, tails, heads, tails, tails. And so I said, well, I need to add those all together to see what my overall result is, to see if it's going to be roughly even. And so what I decided to do was I decided to use, I'm going to model the sum with counters. I'm going to show you how to do it using these counters or these integer circles or something along those lines. Remember that the red circles represent positive 1 and that the blue circles represent negative 1. So what I did was I just wrote out, using the different colors, all of the scores I got from the toss. So I have negative, negative, positive, 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 negative, positive, negative, positive, negative, negative, which is what I have here. What I decided to do was I regrouped, and what I tried to do was put a blue one with a red one. And so I did that as many times as I could, because every time I put a blue one with a red one, it just equals 0. It basically cancels out. So I have 5 pairs, or 5 0 pairs that I can create from the counters that I had. So when I add all that together, that just gives me 0. What I have left is I have this one blue one left that doesn't have a pair. So very quickly I can see that if I add them all up together like that, and I make my 0 pairs, the overall score is negative 1. Okay? So that's one way to use the zero principle, is basically by canceling out a red and a blue, canceling that stuff out to find out what was going to equal in the end. Okay, let's go through a couple of other examples of using sort of a form of the zero principle. What I did here was I just wrote out numerically all of the problems, and again I wrote in blue and red. And what I did was I looked for ways to pair up. So if I have a blue here and I have a red here, and I said, like, if I put those two together, it equals 0. So I went through and made all of the pairs that I could to cancel out. Okay? And when I was done, because it's not going to change the answer, I still had this one blue one left over right there. So that means that my overall sum, when I add all the numbers up, make my 0 pairs, I still get negative 1. Okay? The last thing that I can do is a different kind of regrouping. Second last thing, I can do a different kind of regrouping And I took all of these numbers and I grouped them all together. So I had all the reds and then I had all the blues. And what I saw was I had five reds, I made a group of 5 blues, and then basically that +5 and -5, that just cancels out. Those are opposite numbers. They're each the same distance away from 0. And then when you put them together, it just equals 0. I still had that last -1. And so my overall answer is still -1. So when I add up all those numbers together, that's what I get. Now, I can use that idea to actually solve a question. If I have something like -4 and I want to add it to +2, or I want to add +2 to -4, here's what I have. I have my 4 blue counters, I have my 2 red counters. I can do a little bit of regrouping, and I have 2 pairs that make a 0 pair. So the ones that are circled here just make 0. What I'm left with is these 2 blue counters, so my answer here is -2. What I did over here was I wrote it out numerically, using the colors again, -4 plus +2, and then, again, I use this idea that opposite numbers, when you put them together, equal 0. I split up -4 into 2 -2s, because I'm able to make that 0 pair right there. So that cancels out, that just equals 0, and I still have that -2 left. Okay? So 0 pairs are really helpful when you're adding integers, and I'll show you a way to use them when you're subtracting integers. In fact, 0 pairs, if you're showing them with counters, you almost have to know how to use them. And so you'll get a chance today, or tomorrow rather, to add integers together using the 0 principle. Okay? So, hopefully that's been helpful. Have a great day.